Hello everyone, welcome to our course Reinforcement Learning. As part of this course, in this lecture, we are going to discuss about the deep learning. Okay, so this is the one of the evolution of AI. So more advanced than the machine learning. So what mean by the deep learning? So deep learning is branch of machine learning. It is a part of machine learning, branch of machine learning that uses artificial neural networks with many layers. Actually, this artificial neural network was developed by taking the inspiration from human brain. So artificial neural networks are developed by taking the inspiration or based on the functioning, based on the architecture of the human brain. So artificial neural networks were developed. So in deep learning uses the artificial neural networks with multiple layers to automatically learn the very complex patterns from the large amount of data. Complex patterns from the large amount of data. So high complex patterns identification is very difficult using the machine learning. So deep learning is coming to picture. Whereas to understand the high complex patterns, we need to use the large amount of data. And second thing is, in machine learning, we have to provide the features like one feature is the body temperature, one feature is oxygen, one feature is cold, one feature is cough. Like that, we have to provide the different features, different input features. Whereas in case of the deep learning, the model itself trying to extract the different features from the input data. From the input data, the model itself extract the different features, and based on the extracted features, it comes to the final prediction. So deep learning model from the given raw input data. So raw input data means it may be an image, it may be an audio file, or it may be a video file, or it may be a text file. Okay, whatever it may be from this raw input data. So your deep learning model trying to extract the different features. I said your deep learning model has the many layers. Your deep learning model has many layers. So different layers will extract the different level of features. Maybe initial layers like layer 1, initial layers will extract the low level features like edges, lines and colors. And later some other layer, not initial layers, later layers, they may extract the mid-level features. Mid-level features means eyes, nose, ears, shapes from a given image. And last layers, they are able to extract the high level features. Okay, so like that, at different layers will extract the different level of features from the input given data. In this case, I gave the input data as the image data. Input data as a image data. So if you give this image data to the deep learning model or artificial neural network which contain the multiple layers, at the initial layers it will identify the what's called edges, and it also identify the lines and colors. And the next layers it is able to identify the nose, ears and nose, ears and eyes. And like that it will in the middle layers it will identify the few more features like mid-level features. And the last layers will identify the high level features, which helps to figure out what type of image it is. And based on that, finally your model comes to the prediction whether it is a cat or dog or rabbit with the probability. So it is showing that the given image is a cat with a probability of 99.8, and the given image is a dog of a probability 0.1, and the given image is a rabbit with a probability 0.1. So this is the final prediction with the highest probability is cat probability. So it is showing as the given image is a cat image. So like that your deep learning will works. Like this deep learning models will work. Okay. So in the deep learning models, we can work with images, speeches, videos and natural language processing problems. So machine learning is not performing well with this type of data. So we are going for the deep learning. And the limitations of deep learning are like it needs huge data sets to train the model, to make the model to learn, to understand the complex patterns in the data. So you require the huge amount of data sets, and you require the GPUs, because it take the more computation, so you require the GPUs, and also it take the more computation time, more training time, because we are dealing with the huge amount of data. So coming to the advantages, it learns automatically from the raw data. I said from the raw data directly it will identify the, it will automatically learn from the raw data, and deep learning models are very high accurate. It can handle the images, audio data, text data, and video data, and also it will learn the complex relationships or complex features. So hope you understand how deep learning works. And coming to the next evolution, that is called as reinforcement learning. That is called as reinforcement learning. So I told in the previous lecture, but the same thing may be repeated here. So can you see this answer? A question: can a deep learning model teach a robot to walk? So maybe students may feel that yes, but it is not easy by using the deep learning models, because to make the model, see, I said in the very first lecture, if you want to ride the bicycle, if you want to go for the deep learning approach, you have to provide the different labeled information, the labeled information related to the what happened when the speed breaker came. We have to provide the label information related to the what happened if you suddenly use the front brake. You have to give the label information when there is a high downward slope. So there are multiple scenarios. If the rain is coming, how your riding will be. Okay, if there is huge traffic, how your riding will be. So different cases, to create a labels with all the cases in order to train the model, or to make the student, to make the boy to learn the cycle with a huge amount of scenarios, then you require the huge amount of labeled data. Huge amount of labeled data you have to prepare. So it is very difficult. One thing is you have to put the huge amount of data. Second thing is you have to prepare the labels also. So it leads the increasing of the label cost. It will leads the, you have to invest more time, you have to invest the more effort. So the deep learning approach will not work in such type of scenario. And same thing happening in case of the robot also. If you want to make the robot to walk, walk in a particular environment, so you have to provide the different labels to work as a deep learning. It is very difficult. You have to provide the lakhs of label data you have to provide. That is difficult to train the model how to learn in an environment like a deep learning approach. So instead of that one, we will provide few instructions about the environment. Instead of that one, instead of preparing the lakhs of label data, we will provide the few instructions of an environment to the robot. So then what happened? So instead of using the million labeled images, instead of using the millions of the labeled images, it's better to go with a few instructions about the environment. Later, so leave the robot in that environment, then it starts walking, and it may fall, it may fail, and it get up and starts learn, and it will improve, and finally it walk. So this process will be repeated, as I said earlier. So robot will, in an environment, robot will go with some random action. Maybe it hit by an object, then it will fall, then it understand, oh, this is the, from this position, from this state, this is not the right action, so I have to go with some other action, right? So like that, based on its experience, it starts learning without, instead of giving the lakhs of the label data. So we will give the instructions and allow the robot to learn by itself based on the trial and error. Then it will understand the whole environment effectively. Then it will take a decisions in the environment once it experiences. So this strategy is called the reinforcement learning. I told you earlier class also. So I am making the robot to learn in an uncertain environment by taking the trial and error actions and by receiving the penalties and rewards. So it will start learning, it understanding, it exploring the environment. So once it explores the environment continuously, later it will take a decisions based on its knowledge, what it gained, based on its experience. That's what reinforcement learning is. In the reinforcement learning, you are able to see some terms like environment, where your robot learning, agent, nothing but a robot, how the agent or robot is learning based on trial and error. Based on trial and error, we are giving anything? Yes. If the correct action is there, we will give the reward. If the wrong action is there, the environment will give the penalty. We miss environment. Environment will the penalty. Environment will the reward. So based on that, the the model will start learning and it improve the performance. That's called as the reinforcement learning. Like you try, attempt, you got some error, you got some obstacle, you fail. So if when you fail, you got a penalty. If your action is good, you are moving smoothly, then you got the reward. So finally, you improve the experience, you will improve, and your model will get the better performance. So in the reinforcement learning, models or agents are learning by trial, learning from the error, makes the error and it learn. So this is not a right action because I am getting some penalty. Guided by the rewards. No teacher, no label data, only rewards and penalties. That's it. I want to tell one example, simply explanation for this purpose. Example is, for example, when I went to school at the age of 5 years old, my teacher said, so this, he explained A to Z, he explained everything A to Z. Okay, he gave some information to me, he didn't explain, let us assume, he gave some book to me and understand how the A to Z letters will be there, how the A to Z letters are there. Later, after some point of time, he came to my class and asked, please write A. Then I start writing B. I write this one. Then what he did? He took one stick and hit on my back. That's called penalty. I got penalty. My teacher hit me. I got penalty. When I got penalty means, oh, the letter what I have written, it is wrong. I will not do that one when he asks A. I experienced. Then I will write A, let us assume. Then he give me a 10 rupee as a reward. So I understood that. So when sir asked A, so this is the letter I have to write. So that is what I am learning based on the experience, based on trial and error, based on the rewards, based on the penalty. That's what happening in the reinforcement learning. So hope you understand how the reinforcement learning will work. And the last one, that is called as the generative AI. The current boom, high demand. We are using many generative AI applications like ChatGPT, Gemini, Claude, Store, Copilot, Dolly. So these are the different generative AI based applications. How these generative AI based applications developed? So they are trained with a huge amount of data, text data, image data, code related data. So they trained. The data is maybe taken from the books, articles, websites, research papers. So based on this data, these are called as the large language models, generative AI applications, generative AI models. These are called as the large language models. Those generative AI models are trained with huge amount of data. So once the models are trained, generative AI models are trained, they understand the pattern between the words. So how words are coming together? I am, he is, they are. It will understand that pattern. It will understand some semantic meaning. Okay, the models are able to understand the semantic meaning and they understand the patterns, how the words are coming together. It will understand. Later, if you once the training was completed, if you gave a prompt, like ChatGPT, we are giving the prompt, write an essay about India. Then the ChatGPT writing the some essay in a few seconds for about the India, right? So like that, if you give some prompt, then your model will understand based on its knowledge, it will generate the text because I'm asking essay. So it generates the new content, new text will be generated. Okay, suppose the text is generated as 1,000 words, but I want only 200 words. If I give one feedback, write the essay in 200 words, then it will rewrite the whole content. It will improve the whole content within the 200 words. So it will refine and improve based on the human feedback again. This is how your ChatGPT or generative AI models work. So generative AI learns patterns from data and creates new content. They learns data patterns from the data. The data may be text data, sometimes it's the image data, sometimes like a code related data also. we have some subjects like AI assisted coding. So what are the large language models we are using? They are trained on where code repositories like GitHub. So they understand what is the syntax of the different programming languages. According to generate the code when you are asking any prompt. Write a code using Python to check the prime number. It will write a code because it knows how Python code will be, what are the syntaxes, what the logic, to understand everything. So it learn and create the new content. So no humans write each answer. It does not memorize. Does not memorize. Based on its knowledge, what it gained, based on the training process with the huge amount of data, it will generate the new content. It is not like a by heart and reproduce. No, think and generate. It predicts the next best words based on the patterns. Based on the patterns, it will understand what will be the next word. Accordingly, it will generate the text. It creates a new and original content every time. Okay. So generative AI, learning from data, understanding the patterns, and create the new data. Right. So this is how generative AI applications develop and how generative AI will work. So this is the complete summary of the evolution of artificial intelligence. First, symbolic AI based on the rules, programmer rules. Expert systems based on the rules are prepared by the programmer in presence of expert knowledge. In machine learning, the model discovered the rules based on the given input data. No one prepared any explicit rules. So during the learning phase, here there is no learning, here there is no learning because we are preparing the rules directly. But in case of the machine learning, the model learns and discovers the rule. Similarly, in the deep learning also, model learns and discovers the rules, but complex relation will be developed for the complex problems, especially when you are dealing with images, audio data, video data, text data. And the reinforcement learning, here also your models will train, models will learn, but based on the trial and error, based on the reward and based on the rewards and the penalties, based on the feedbacks. Okay. And the last one is generative AI. So in the generative AI, it's also generative AI models will learn based on the large scale data, the data related to text, data related to the images, code, and audio. Examples are for generative AI like ChatGPT, Gemini, DALL-E. These are the different examples, and what we discussed is available in the last call. So our topic is reinforcement learning. So reinforcement learning is the bridge between learning intelligent decisions, bridge between learning and intelligent decision making, which is why it is one of the most exciting area in the AI today. It will learn based on the trial and error, and it will take the intelligent decisions. Okay, so artificial intelligence has evolved from machines that follow rules, symbolic AI, to machines that learn from data, discover the rules, to the machines that learn from the experience, reinforcement learning. Now machines that create entirely new content. They prepare the new data. That's how the AI is evolved. Initially, rules, we have to provide the rules. The application follow the rules given by the programmer. Later, machine itself prepare the rules from the data. Later, machine learns from the experience. Now, the machine will generate the new content, generate the new data. This is how the evolution of the AI happened. So hope you understand the evolution of AI, and in the next lecture we will discuss about the different learning strategies. So we will meet in the next lecture. Until then, bye. Thank you.